Okay, so problem number 5. A squared minus 9a plus 22. Okay, we're going to do our 5-step method. Now here's the thing. First step, GCF. Is there one? If there's not a coefficient in the first part, then there's no GCF. In other words, you got a 1, a 9, and a 22. Now, that's not necessarily true, because if I had an a squared, a squared, a squared, then the GCF would be a squared, right? And I could pull those out. So, not necessarily always true, just mostly true. If there's a 1 out front, there's probably not a GCF, unless it's a variable GCF. So how about that? We list it as no GCF unless it's a variable GCF. Here, there's no variable GCF. There's just no GCF. So 2. What's our second step? So it goes GCF,
Variable.
and then variable, star variable, remember, star variable, and parentheses. So there's a lot to it. Remember, our star is that first coefficient. If there isn't one, then there's no star. Okay? If there's no star, then there's no 5th method. There's no 5th step. So that's a cool thing to remember. No star, no 5th step.
So the star, what would the star be? A
The
number?
first coefficient. So,
a number?
a number. Yeah, the first number out in front. A number out in front. So a lot of times it's like in, well, in the next one, it's a 3.
Okay, that's a coefficient.
Yeah. Yeah, the coefficient is the number in front of the variable. The second coefficient here is 9. A coefficient is just a number.
Yeah.
Yeah, sorry.
I was like, what?
Using those big words again, I'm trying not to use. Coefficient is just a number that's in front of the variable. The first coefficient is the first number in front of the first variable. The second coefficient is the second number in front of the second variable. The third coefficient is the third number in front of the third variable. But remember, you don't see a variable here, right? But there is one, it's just to the 0 power. So, they just mess with you. Okay? It's just one of those weird things. Remember, to the 0 power means it's just the 1, and a 1 times 22 is still 22. And okay, getting a little bit complex
Yeah,
here.
I'm sorry.
Don't have to go that far. But just remember, coefficient are numbers. First coefficient, second coefficient, third coefficient. Okay? So, thing is, first number is your star. There's no number, there's no star. There's no star, there's no star cleanup, which is your 5th step. No 5th step. So if you don't have a star in the beginning, you don't need to clean it up at the end, right? Make sense? Okay, so what we got to worry about is, and I'm going to change the color on these, is this still. So my parentheses and my variable. What is my variable? So I put in my parentheses. I have 2 parentheses, and my variable is A. And how many A's do I have? 2. So there's 2. Make sense? Okay? If I had 4, then there would be 2 here and 2 here. If I had 6, there would be 3 here and 3 here. Make sense? Because 3 and 3 is 6. 2 and 2 is 4. And 1 and 1 is 2. Okay? So, I've done that. So let's change color again. 3. What is my third step? Signs. This sign goes right there. Right off the bat. Whatever the sign is, bring it down. That first sign gets brought down. And then I look at this sign. If it's positive, it's a sum, which is the same. If it's negative, it's a difference. Or it's different. Alright? So, same means that these two signs are the same. Since this is the same, it tells me that these two signs are the same. So they must be minus. Okay? Because this is a same problem. Okay? Now the other thing is this last step right here. Fourth step, product and sum. Okay, the product is the first coefficient with the last coefficient, the product of the two. So you multiply them. In this case, it's just 1 times 22, which is 22. Okay? The sum is the middle coefficient, which is 9. Now the only other thing I need is to know about the sum. Remember, the sum comes from these two. In this case, it's coming from the one that's circled, which is the same. The same is plus. So that's what we're doing here. If it were minus, then we'd be doing a difference problem, and we'd be subtracting here. But it is a same problem, or a sum problem, so we are adding two numbers. So I need two numbers that multiply to be 22, but add to be 9. Add to be 9. Multiply to be 22. So with two numbers, so I could go, okay, 11 and 2. Always biggest number first. Always big number first. Absolutely, positively, must do, always big number first. 11, 2.
This is still step number 2.
Yeah. No, this is step number 4. Sorry. Here's the thing. 11 and 2 sound right, but are they right? Is 11 times 2 22? Is 11 plus 2 9? No. 11 minus 2 is 9, but 11 plus 2 isn't. Is there any other two numbers? What about 22 and 1? No? So, no? No? Can you think of any other numbers that go into 22? No other numbers go into 22. Oh, it doesn't work.
So it'd be prime.
It looks like it works, but it doesn't work, so it will be prime. This is one of the few primes. Believe me, I get all the time students are like, oh, this one's prime, this one's prime, this one's... No. Okay? Once you find one prime, there's probably not going to be another one. Okay? It's usually one prime on every test.
With little sum and stuff.
The way they make, they're messing with your head. They want you to pick up 11 and 2.
No, you threw me off.
Oh.
You're getting 22 and 9 and adding them to what? To 1?
Well, what is 22 plus 1?
23.
23. I'm taking the same ones that I'm multiplying to get 22, and I'm trying to add the same numbers to get 9. That's the key to finding the factor. I need two numbers that multiply to be 22, the product, and two numbers that add, in this case, because it's the same problem.
If it was a subtraction.
If it were a subtraction problem, right? So now you just figured it out. If and this is a big if, but if it were this, right? Now what would it be? Minus, this is different, so they are different. So it's minus plus.
Wait up.
That says it's different. Different means different, that these are different now.
Okay.
So different minus plus. And now this would be minus. So this is 22 still, this is still 9, but this is 11 and 2 multiplied to be 22, right? Do they subtract to be 9?
Yes.
Yes. So 11 and 2. So that would be a factor of this problem, but not this one. This one is prime. And so they're messing with your head. They're trying to see, oh, do you know what it means to factor it? Or do you just know how to factor the numbers out and get them to be 8, 11, and 2? Right? So, do you know what it means to be totally factored? Okay, so here can't happen because I know my rules. Here it can happen because I know my rules. In this case, it's a difference problem. So we are subtracting or adding negatively, right? So 11 minus 2 is 9. What does this number have to be in order for it to work? 11 plus 2? 11 plus 2? 13. So this would work if this number were 13 or 23. So this number could be 13 or 23 and it would work. Because these two numbers multiply to be 22 and add to be 23, or multiply to be 22 and add to be 13. So there are ways it could work, but you'd have to change it in order for it to work. And that's why we're not changing it. It's prime. It doesn't work. Okay? Now that one you might have to rewind, pause, go back. There's 12 minutes here. That's good.